Good evening, everyone. We will start the meeting in 5 minutes. So, today we will discuss seventh assignment on the nature and properties of material. This is the introductory course. So, let's start the meeting. Uh, for today's session, let's discuss the first question. First question: which of the following polymer has a regular alternating arrangement of side groups? So, option is atactic polymer, isotactic, syntactic, cotectic polymer. So these are the options. Which of the following polymer has a regular alternating arrangement? Regular alternating arrangement of side group. Option A, B, C, D are given. So if you have idea, you can write a correct answer in chat box. So answer is C. Syntactic polymer. And let's discuss a tactic polymer which has random arrangement, random placement of side group. Like that we can see here is a carbon atom and H atom. So taking another color, this is H atom and also has vinyl like that, side group vinyl group, chlorine vinyl side group. So this is a random arrangement. This is for a tactic. If the random arrangement side group, which is known as a tactic polymer. Okay, second, isotactic, side group being placed on the same side. Some you can see the picture, isotactic. H atom are like that, and also the mineral group same side. While third is syntactic, which is regularly alternating arrangement of side group. You can see the picture. This is back, this is front, back, front, back, front. Okay, so this is the first question. Second question, the repeat unit in nylon are linked together by aldehyde group, amide group, hydroxyl group, amine group for nylon. The repeat units in nylon are linked together by aldehyde group, amide group, hydroxyl group, amine group. Which is correct? So let's see the answer. Amide group, and you can see nylon structure. This is a polyamide group. C double bond O and H, and you can see C double bond O NH. So this is the repeat unit for amide. Lylone is amide group. And between has a hydrogen bonding. Okay. Next is elastomer. What is elastomer? Demonstrate rubber-like elastic behavior. Okay. Long chain molecule with the same degree of cross-linking. This is a long chain molecule with same degree of cross-linking and excellent binding recalling properties. This is, you can see, mobile part at room temperature. This is cross-linking and few hundred of nanometers. This is the main chain for elastomer and this is cross-linking. Next, let's see the natural rubber. Rubber isop isoprene molecule has this and time of repeat units isoprene, and if these double bonded are broken, then this is okay. So this is natural rubber. For natural rubber, if we do vulcanization treatment with this, then what happen? We will discuss in next question. The vulcanization of the natural rubber take place by its treatment with bromide, phosphorus, fluorine, sulfur. Which one is correct? So sulfur is the answer. Here is a sulfur. This is provide cross linking. Next question. Which of the following is correct for polymer? Thermosets polymer often soften open heating, vulcanization, rubber, epoxy, and phenolics belong to the class of the thermosets. Cross-linking is the characteristic thermoplastic polymer. Thermoplastic polymer have linear end branches. So please choose the right options, which is correct for polymers. So vulcanization, rubber, epoxy, and phenolics belong to the class of thermosets, and thermoplastic polymer have linear and branches structure. We can see thermosets example, vulcanized rubber, epoxies. So this is vulcanized rubber, epoxy, phenolics, polyester, bakelite are the example of thermosets. Why? Type of polymer: thermoplastic thermosets. Thermoplastic polymer have linear and branches structure also. Next question. The electronic transition take place from K cell to L cell to K cell. Emits which of the following? Characteristic X-ray radiation. Option first: K alpha, K beta, L alpha, K gamma. Let's see. This is K, L1, L2, L3, and transaction take place from L cell to K cell, which is known as characteristic alpha X-ray, which K alpha, K beta, which one? Yes, please, anyone answer this question? So answer is K alpha. Let's see. There is a picture taken from the lecture, and you can see K alpha, K beta, K gamma. If transition from L to K, this is known as alpha. If M to K beta, if N to K gamma, or M to L, L alpha, L if M to N beta, M sorry M to L beta, N to M gamma. You can see here is a L cell, here is a K cell. Transition electron jump from L to F and emitted radiation, which is corresponding to the X-ray characteristics known as K alpha. If M to K, K beta, and this is corresponding to K gamma, N to K. And energy we can calculate by this formula respective to the transition. If incident has photon energy. So next question, which of the following metal is used to filter out K beta component from the copper X-ray radiation? Nickel, molybdenum, chromium, cobalt. Yes, please. So answer is nickel. You can see we can see If we know the X-ray undergo the absorption by these metals, this is equation I equal to I naught exponential e decay mu rho by rho x. Okay, and this is plot X-ray versus mu alpha. Here we can see, let me take a particular. This is K beta H, then alpha. This is Cu copper, and absorption we can see K alpha of the copper. So K alpha nickel absorption lie there. If we use copper source for copper K alpha K beta, then filter, we need a filter of nickel for to absorb the copper beta and filter out the component from the X-ray radiation. Okay, next question: which of the following statement is true about the characteristic K radiation peak in X-ray? There are the order of K alpha, K beta, K gamma, K alpha 1, K alpha 2 and K beta, corresponding to the radiation taken from the material. So please choose the right option. Which one is correct? Wavelength of K beta is greater than K alpha and K alpha 2, K alpha 1 and K alpha 2. There are the orders you can see in A, B, C, D option, and please pick up the right statement. You can take 2 to 5 minutes for this question, then I will discuss. So let's discuss. Answer is C. wavelength of K alpha 2 is greater than K alpha 1 and greater than K beta. Why? Let's see. We know if transition from L to K is corresponding to the alpha, K alpha. If and for L there are subcells L1, L2 and L3. If transition from L3 to K, which is corresponding to the K alpha 1, if transition from L1 to K, which is corresponding to the K alpha 2, so which is high for energy, we can see the difference between K and L third. Transition from L third to K is greater than L1 to K. So energy is high for K alpha 1. Yes, compared to energy of K alpha 2. So we know equal to Hc by lambda. Energy is inversely proportional to the lambda. If energy is high, then wavelength will be low. So order will be for lambda K alpha 1 is less than lambda K alpha 2. Okay, and lambda K beta, we know transition from beta is M to K. This is corresponding to K beta. So energy is greater than 4 K beta highest, then energy of K alpha 1 then last is K alpha 2. Energy of K alpha 2. So wavelength will be inverse in order. Okay, so clear to you this question? If anyone has doubt, please you can ask. So option C is correct. Next question. Which of the following X-ray radiation is most studied to characterize iron containing materials? Molybdenum K alpha, copper K alpha, chromium K alpha, cobalt K alpha. Yes, please answer. Most studies for characterize iron containing material. So answer is C and D. Chromium, calfa, cobalt, calfa. You can see wavelength of iron containing material will be 1.94 angstrom around. So we can use cobalt which is near to Fe, and also we can use chromium which is around 2.29 angstrom wavelength. Next question: which of the following is true for rotating crystal methods? For rotating crystal methods, wavelength of X-ray is fixed, or wavelength of X-ray is in range, diffraction angle is fixed or variable. These are the options. You can choose the correct options. So let's discuss. Wavelength of X-ray is fixed for rotating crystal, and diffraction angle will be variable. You can see in slide single crystal variable wavelength for lever methods, but rotating crystal methods fix the wavelength and angle will be vary. Next question: which of the following method can be used to determine the crystal structure of single crystal? Lave method, rotating crystal, powder method, Debye method. Debye's error method. Which one is useful for single crystal? Determine the crystal structure of single crystal. Yes, please. So answer is we can use Lave and rotating crystal methods for single crystal. Okay, you can see in a screenshot also. Sir has discussed variable single crystal. We can use Lave method and rotating crystal methods. Next, the short wavelength limit lambda SWL in angstrom for 16 kilowatt X-ray tube voltage is, and Planck constant as x, light speed and electronic charge are given. Please calculate the short wavelength limits for 16 kilovolt X-ray voltage tube. You can take 5 minutes, then I will discuss. Please try this question. Okay, C option. So let's check the option. Yeah, you are right. Option C is correct. So let me discuss also. We can see intensity versus wavelength. If we apply voltage in the 4 X-ray tube, 5 volt, we will get like that a spectrum, 10 volt, 15 volts, kilovolts, sorry, 20. Increasing the voltage 5, 10, 15, 20 in kilowatt and 25 particular for voltage kilowatt, we will get characteristic radiation from the sample also, and we will get also the short wavelength limit. So this is corresponding to, we know, like the incident energy equal to the tube voltage. This is the tube voltage in electron volt, and we know the energy is conserved, so energy will be emitted by in the form of photons or X-ray, characteristic X-ray, like that h nu. Let's equal this, and we will be converting hc by lambda electron volt. Sorry, this is volt. So if we hc by av, this is corresponding to the shortest wavelength emitted from the sample. So this is the formula, and h nu, if we put Planck constant, speed of light and electronic charge, we will get 12400, and V if we apply in volts. So please put the value 12400 and 16 kV, 10 to the power 3. Okay, 12400 divided by 6, 5, 2, 3. This is 0.775. Okay, in angstrom. This is in angstrom. Next question. The Bragg angle food 111 deflection plane from simple cubic structure material is Bragg angle is 24.6 when it is expected exposed to X-ray wavelength 1.54 angstrom in diffraction experiments. What is the lattice parameter of the material? Option A, B, C and D are given. Please choose the right option. First, please calculate, then choose the right option. You can take for discussion also 5 minutes. Okay, option B. Let's check. Option B is correct. So you know the formula for XRG 2D sin theta equal to n lambda first. N will be here is take 1, lambda is given, so 1.54 lambda is given, 2D, and t equal to we know HKL is 1 sin theta, and from here 1.54 root 3 divided by 2 sin, put the value of theta 20.6. If we solve this question, you will be get the approximate 3.2 in angle. Okay, for next question, the interpolating spacing between the 101 plane of abscissa lattice parameter is given. So please calculate. You can also take 4 5 minutes. Then I will discuss. So let's discuss this question. Interest the interplanar spacing between the planes. FCC lattices. Option A is correct, but let's see how. H equal to 1, 0, 1, and A is also is given. We have to find out the D. For FCC, we know the D equal to A. We can apply this formula. So please put the value in this formula. Simple cubic also for FCC. Three point nine divided by so this will be 2.758 or from 2.76 approximate. So option A is correct. Let's move for next question. An X-ray beam of wavelength 1.5 angstrom is incident on FCC crystal a center cubic. Lattice parameter 2.8 angstrom. What will be the lowest value Bragg angle in degree of second order reflection? So option are given. It is in degree. So we know 2b sin theta equal to n lambda, and here is 2 lambda 1.54 in angstrom. A is 2.8. This is FCC, so we can also correlate A and D. So apply these two formula, first and second. You can calculate theta. Okay, so please use these two formula, put the value in these two. H equal to 1, equal to and L equal to 0. Please calculate the value of theta. You can take 5 to 10 minutes for this question. हेलो हाँ कृष्ण मैं बंसी पैकेट में हूँ नहीं तुम लोग चलो कहाँ कैंडी नहीं तुम लोग चलो मैं करता हूँ So please answer. So let's put the value here. 2 d equal to, we know what is a 2.8. We have to find the value of second order and then the limestone. This is in limestone. This is cancelled out. It will also cancel out. And then what is the value? 1.54 divided by 2.8. It's around. Answer is C. C. So this is what is this value? It's 50. Okay, so we can solve like that question. Next question, pick up the correct statement. XRD, for regarding XRD, diffraction occur in a specific direction along which the consecutive interference occur. First option. Second, X-ray can easily penetrate metal because they have longer wavelength. Modern X-ray refractometer using scintillator or CCD detector to record the angle and intensity of the diffracted beam. K beta radiation has low energy but high intensity in comparison to copper K alpha. So we know this is wrong. K alpha energy is higher than the K beta has energy higher than K alpha. Modern X-ray refractometers based on scintillator or CCD detector. Yes. And X-ray easily penetrate metal. No, this is wrong. Longer wavelength. Sorry. So and diffraction occur in a specific direction along with the consecutive interferences occur. Yes. We can see diffraction for consecutive interference. This is the specific angle and wavelength should be the part difference or phase differences and and pi for constructive interference and part difference and lambda. So next will be we will discuss Anderson patterning. We can see 2d sin theta equal to n lambda, or this is equation first, d for cubic system. If we use these two equations, we will get this equation. Okay. For identification of graphs, primitive, body center, face center, these are the constraints. Primitive 1, 2, 3 HKL square values will be 1, 2, 3, 4, 5, 6, 8, 9, 10, 11, 12, dot, dot, dot. For body center 2, 4, 8, 10, 12, 14, 16. Face center 3, 4, 8, 11, 12, 16, 19, so on. Selection rule for presence or absence reflection. Primitive all reflection, present, absent, none. Body center HKL plus H plus K plus L should be even, and absent for H plus K plus L will be O. Face center H, K and L are mixed, all even or all odd. If absent, then they are mixed. So let's do a calculation. If 2 theta are given, then we will be calculate this is theta value. For the theta value HKL and type of crystallist will be BC simple cubic or center. So we have this equation. Rearranging, we can calculate A, lattice parameter. First, 2 theta are given, these are given, and this is also given. So let's calculate corresponding to sin square theta. These are the sin square theta. This is first step, sin square theta, calculate. Then second, divide this sin square theta value by minimum of sin square theta in this row. So this is minimum sin square theta divided by sin square theta minimum, and then this is the value. Then multiply a number, then we will get the perfect integer. So we can multiply 1, 2, 3, 4. So here if we multiply by 3, then we will get 3, 4, 8, 10, sorry 11, 12 approximate. So this is equivalent to multiply by n, h square, k square, l square. So 3, 4, 8, 11, 12. This is corresponding to body center. Sorry, face center cubic. And HKL, if HKL square is 3, then HKL will be 1, 1, 4, 2, 0, 0, 8, 2, 2, 0, Okay, corresponding, if we apply this formula, then we will get the lattice parameter. Okay, so this is the procedure. We can determine the if crystal has FCC, BC, or a simple cubic. And this is the we can calculate like this type first calculation, or we can use second methods for this. For second method, we can use sin square theta equal to a. This is lambda square by 4a square corresponding to the a. How we can get this is simple. Let's discuss this. 2t sin theta equal to n lambda, and it will be for cubic system. Put the value of t in this equation and rearrange to a, let's square 4 a square h square k square n square n square lambda square. If we and also the sin square. Sin square equal h square k square l square n square lambda square divided by 4a square. So assume this is constant. So okay, like this we can calculate. How we can use, let's see. If 2 theta are given, then calculate sin square theta, then divide by 2, 3, 4, 5, 6, 8, like that. 1, 2, 3, 4, 5, 6, 8, and choose the lowest minimum value, lowest common sin square value. So we can see this is minimum value, this is minimum value, least common value. After this, sin square we have already, and from this least common value will be a 0.0363. According to the equation, we can also calculate here a small a by putting this in this formula. So, and also if we divide by a, then we know we have sin square equal to a h square k square l square. So divide by a, then h square k square l square 3, 4, 8, 11, 12, 16, 19, 20. This is also abscissa and corresponding to the HK. So these are the two methods. You can determine the crystallic structure if the two theta are given. So this is the, let's calculate the this two theta are given, then calculate sin square. Fifty 54.41 and sin square 0.1428. Okay, then 64.59 divided by 2. This is 32. Take sin square 2854. Okay, then 81.77 divided by 2. Take sin square 428. Similarly, 90.26 divided by 2. Take sin square 57.15.34 divided by 2. Sine square 71399 and 135.47 divided by 2 square 20.6. Sine square by sine square minimum, this will be 1. Point 2 5 point divided by point 428 1. Similarly, point 1 zero 7139 divided by 0.1428. Similarly, 0.856 so if you multiply by simply 1, this is around 1, 2, 3, 4, 6. So HKLR 1, 2, how to 1 square 1. This is 2, 3, 1, 4, 2, 0, 0, 5, and 6. 2, 1, 0. This will be 6. Okay, so we have to calculate A. This is HK 1, 2, 3, 4. This is will be simple cube. If we h square, k square, l square, 1, 2, 3, 4, 5, 6. This is corresponding to the simple cube. Yes, we know. So these are the two theta experimentally plotted, but we have to calculate A. So what is the formula for A? We have already seen into lambda by 2 sin theta square root h square k square l square 2 sin theta h square. Okay, please apply this. Then you will get A. Let me calculate 4 first. Then lambda is 0.154 in nanometer. 2 sin theta 40.41 divided by 2 0.3779 h square k square 1 0 0. So this will be 1.54 nanometer 0.7558. This is 1. This is around 0.203 nanometer. Okay, so similarly you can calculate for this rest. So this is the procedure. You can find the lattice parameter and crystal structure, simple cube, or body center or a facet. Okay. Second question. This is similar like question, same, but this is different methods. First you calculate sin square theta. We have already calculated. And then multiply by divide by 2, 3, 4, 5. Then choose the least value. Also, theta is previous, so sin square will be same 0.2854, 0.428, 0.756. Okay, so divide by 2, 3, 4, 5. 0.428. And this will be 0.0714 and 0.28, 0.27, 2.5, 7.39, 6, 6 divided by 2, 4 to 8. Similarly, divide by 3, 4, 8, 5, 6, divide by 2, 8, 5, 3, 3. This is 2, 4, this will be 7, 2, 6, 6. This will be 4 to 6. This will be 0, 7. Okay. Similarly, you can calculate these values. Let me calculate first 0.1228, 2, 3, 4, 7, 6. This will be 3, 7, 0, 2, 8, 5, 6. This will be 2, 3, 8. Similarly, next to it, 5 4 3 4 3 0 3 5 6. Similarly, next point 4 0 7 0 6 next 6 1 4 3 6 7 5 3 0 7 4 7 next point 7 3 now. This will be 2 3 7 1 7 2 1 7 this this will be 9 2 3. So these are the numbers. Now please find least value. Common least value. Similarly, we have already found. Let me show you here. Least common value. which is common values. Please pick up the common values, then we can let's see these are the okay, this is common value and other. This is also other two. No, 0.35, 4, 0.014. So this is the list value, and we can see 1 divided by 1, so h square k square l square 1 2 3 4 in first, second, third also, fourth also, fifth also, sixth also. So these are the HKL square 1 2 3 4 5 6. So this is the simple cubic. Okay, you can find the A value will be 1.423. So here you can apply equal to f divided 2 root 8. Here 2 you will get A will be 0.023 strong, so in nanometer, and sin square we have already value divided by A. What is the sin square? 0.28, then 0.2854, 0.428, 5718, 7139, 856. Then divide by 8, we will get 2. This is approximately 2.428 divided by 3, so 3.57, 0.7139 divided by 1.43. Last 0.856 divided by 0.1423. So this is maybe HL 100 These are the so these are the two type methods. This is second methods. This is first methods. You can get the knowledge about the crystal lattice parameter and type of simple cubic abscissa or body center. So we have to remember these rules. If primitive simple cubic 1 2 3 4 body center 2 4 6 face center 3 4 8 element value of HAL is 1, and you can relate these formulas. So this is all about today lecture. If any doubt you can ask me. Yes, please. If you have any doubt you can ask. If not, then we will ending the meeting. Thanks.